Hi Year 11, this is our first video for the current situation with the coronavirus. You'll be getting video lessons from me now combined with notes which you will need to print out. Now you've already got a copy of this document and I've posted a copy on Google Classroom if you need to print it out again. So let's have a look at the discriminant. Okay, so first of all, the solutions of an equation are called the roots of the equation. So if you look at this equation here, that I'm underlining in green, the solutions to that equation are called the roots. And how do we find the solution to that equation? So we use the quadratic formula to solve that quadratic equation. Now, in the quadratic formula, we know that there is the b squared minus 4ac part, which is just there, and we call that part of the quadratic formula the discriminant. So the b squared minus 4ac part is called the discriminant, and we abbreviate it with the symbol delta, which is just a triangle. So delta is equal to b squared minus 4ac. So if you look at our first question now, let's have a look. It says use the quadratic formula to find out how many real roots each quadratic equation has. Okay, so let's have a look at the first one. Now, x equals minus b, which is minus 8, plus or minus the square root of b squared, so 8 squared minus 4 times a, which is 3, times c, which is negative 2. Okay, that's all divided by 2 times 3. So it gives us x equals minus 8 plus or minus the square root. Now get your calculator out, work this out. You're going to get 64 minus 4 times 3 times minus 2. You're going to get 88. All divided by 6. So how many real roots do we have to the equation? So here's our equation. How many real roots do we have? We have 2 real roots. Well, the first real root is x equals minus 8 plus the square root of 88, all divided by 6. I'm trying to squeeze in the other one. And the other real root is x equals minus 8 minus the square root of 88, all divided by 6. Okay, so that's one root, and there's the second root. Next question, let's have a look. Now, I should have done this before, but in this one we have a equals 1, b equals minus 1, oops, b equals minus 1, and c equals 4. So, putting that into the quadratic formula, we get x equals minus b, which is minus 1, plus or minus the square root of b squared, minus 1 squared, minus 4 brackets a, which is 1, brackets c, which is 4, all divided by 2 times 1. So that gives me x equals, now minus 1 is 1, plus or minus the square root of, now put this into the calculator, minus 1, now put this in brackets though, so brackets minus 1 brackets squared, minus 4 times 1 times 4 equals negative 15. All divided by 2. Now, that was a 4 there. Okay. Now, you can see here we've got a negative 15 inside the square root. You cannot find the square root of a negative number using the real number system. So we say, therefore, there is no solution, okay, to the equation. Now what does that mean? Therefore, no real roots. Next. Okay, so we have this one, A. We have A equals 1, B equals -2, C equals 1. Alright, so put that into the quadratic formula. You can x equals minus b. Now minus -2 is just positive 2. Then plus or minus the square root of b squared, -2 squared, minus 4, and then a, and then c. All divided by 2 times a, which is 2 times 1. So it gives me x equals 2 plus or minus. Now, in the brackets, you're going to have minus 2 squared is 4, minus 4 times 1 is 4, so 4 minus 4 is 0. So there's 0 inside there, -2. Now, what does that equal? That equals 2 divided by 2, which equals 1. Okay, so there is one real root, right? And what's the real root? The real root is x equals 1. Next question. Okay, so here we got A equals 3, B equals 13, C equals -10. I should point out that these examples, or some of them I think, particularly this last one is slightly different to the first time we went through this in class. I thought we could use better examples second time round. Okay, now, trying to do the quadratic formula into this little space. Let's have a look. X equals minus b, so minus 13, plus or minus square root of 13 squared minus 4, brackets, 3. No, I'm not going to have room. Okay, let's rub this out. Try again. Okay, I'll come down here a bit lower. So x equals minus 13 plus or minus the square root of b squared minus 4 times 3 times -10. All divided by 2 times 3, 2 times 8. So it gives us x equals minus 13 plus or minus. Now you work that out in the brackets, what the square root part is. You're going to get 13 squared minus 4 times 3 times -10, which should be, let's check the calculator, 13 squared minus 4 times 3 times -10, 289, which I know is a square number, divided by 6. So you're going to get x equals minus 13 plus or minus. Now, square root of 289, if you work it out on your calculator, that's 17. Okay, divided by 6. Now, I don't think I've got any more room to add to the bottom there, so I'm going to have to try and squeeze this part in. Now, let's have a look. So, I've got -13. I'm going to add 17 and then divide by 6. So, that's going to give me 4 divided by 6, which is 2/3. And then the next part will be the -13, but this time it'll be the minus 17 divided by 6. So minus 13 minus 17 is minus 30. Divided by 6 is minus 5. So minus 5. So the two roots are, well, there's actually two real roots, isn't there? Two roots. Okay, there they are. Okay. Alright, next. Alright, so the roots, let's have a look at the roots. We're going to have to go back for the first one. So So for our first equation, what was it? Minus 8 plus or minus root 88 on 6. So I'm just going to put down the number of roots rather than what the roots are. So 2 roots. Okay. Okay. Now, what about the next one? X squared minus x plus 4, if we go back to that, x squared minus x plus 4, that's got no roots. Okay, so we've got no roots. Okay, next one, x squared minus 2x plus 1. Now, x squared minus 2x plus 1, that's 1 root. Okay, so we're going to write down 1 root. Okay, then the last one we had 2 roots, didn't we? 2 roots. Okay. Now, what about the discriminant for the first one? If you go back, what's the discriminant for the first one? It's 88. So I'll go back and put 88 there. Okay. The next one, x squared minus x plus 4, that was minus 15. The discriminant was minus 15. Next one, discriminant was 0. Okay, so go back to 0. And then the last one, we had discriminant 289. Okay, 289. So the number inside the square root is called the discriminant, as we know. So all of these are equal to delta, delta, delta. Okay, now let's see if we can write a bit of a conclusion about this. Now if delta is negative, then how many roots do we have? Well, look at this. Here's delta negative, and what does it say? No roots. So I'd write down no real roots. Okay, let me just tidy that up a little bit. No real roots. Okay, now what if delta is bigger than 0? Delta bigger than 0 is whereabouts? Here we go. Delta is there, and delta is there. Okay, so if delta is bigger than 0, then I'd say it's got two real roots. 2 real roots if delta is bigger than 0. What if delta is equal to 0? If delta equal to 0 is just here, you can see that means we've got 1 root. 1 root. Or sometimes they say 2 equal roots. 2 equal roots. Now why would they say 2 equal roots if it's got 1 root? Well, the 2 equal roots is this equation here. So if we come down to that last bit. So x squared minus 2x plus 1 can be factorised as x minus 1 all squared. Okay, here's our equation. Now, if I write those two factors separately, I get x minus 1, x minus 1. So, technically, the only root we have is at x equals 1. Okay, so x equals 1 is the solution to the equation. That's our only root. But because it's repeated here and here, they say that the 2 roots are equal because we've got two repeated factors, x minus 1, x minus 1. So that means we've got 2 roots with the same value. Okay, now what about the nature of the roots? If delta is a square number, well, if you work out delta here, what can we say about delta being a square number? So if you work out delta for this one, it was 289. Right? Go back to your table, have a look. It's the very last one here. There it is, 289. Okay, so what can we say about that? Well, we can say that the roots are, now you've got to choose one of these, either irrational, rational, or real. If you go back to that one, 289, here it is. Now what happened to the roots? Have a look. Here we go, there's one root and there's the other root. Now these roots are fractions. They can be written as fractions. Negative 5 is a fraction because I can write it as negative 5 over 1. So that means we know that if delta is a square number, the roots are rational. Right? We also know they're real. Now remember, real numbers just means any number which is rational or irrational. So if it's rational, it's definitely real. Now, what if delta is not a square number? So delta is not a square number. So if we go back here, that's the first one here. This equation here, when you work out delta, here it is, there's delta, it's 88. That is not a square number. So if you go back to the previous page, have a look. Here it is. Delta is here. What can I say about the roots? Well, the roots are square roots. You can't simplify those square roots to whole numbers. So there's always going to be a surd in your solution there. So that means because we can't write the roots as fractions without the square root, that means the roots are irrational. Okay? So the roots are irrational. Okay? And since irrational numbers are also part of the real number system, we can say rational and they're also real. Now, okay, here's a little tip for you. If delta is a square number, the quadratic can be factorised. So if you want to do a quick check to see if a quadratic can be factorised, you just find out what the discriminant is, and if you get a square number, then you know it can be factorised. Okay, so for example, square number. So notice that, that should have gone actually up here, shouldn't it? Whoops, that should be going up there. So that bit there, cross it out and write it up here. Okay, that's a mistake in my notes there. So here's your delta as a square number. Delta is 289, and look, I can factor this. Have a look. 3x, x, and then I've got 5 and 2, positive and negative, equals 0. There you go. So if delta is a square number, you can definitely factorise it. So that's a good tip. Okay. Now, if delta is bigger than or equal to 0, now what I'll do is I'm going to correct those notes. So when you see those notes on the PDF, I would have fixed it up, hopefully. Now, what if delta is bigger than or equal to 0? What can we say? So let's go back up here. Now, if delta is bigger than or equal to 0, so we're looking at this case, and this case. Okay, so the three red stars or asterisks. Now, if you look at the first one, we said that the roots were irrational. Irrational roots there. If you look here, we said the roots were rational. Yep. And if you look at here as well, we said that it's got one root or two equal real roots. So actually, if you go back to that one where it's 0, you can see here. Here we go. So we will classify this as one real root, but also we'd also call it a rational root because I can write 1 as a fraction. Okay, so coming back to here, If delta is greater than or equals 0, then the roots are real and not necessarily rational. So I think it's just real roots then. Yep. So let me just scribble that out. So just going back to that. Here we have the 3 stars. Each one of those, the roots were irrational here, rational here, and rational here. So rational or irrational, that means the roots are real. So for that last one there, the roots are real if delta is bigger than 0 or equal to 0. Okay, now what about the discriminant and the parabola? Okay, so the roots of the quadratic equation are the x-intercepts of the parabola. That's one thing to note. So when you solve this equation, you're actually finding the x-intercepts of the parabola. So let's look at the first one. If delta is bigger than 0, then the quadratic equation has 2 real roots and the parabola has 2 x-intercepts. So when we solved this, we got delta to be 88, I believe. Yep. So if delta is 88, that means the parabola has 2 real roots. So here's 2 examples. Here's a parabola with 2 x-intercepts, and here's another parabola with 2 x-intercepts. This one is concave up, this one is concave down, and both of these parabolas here would have a discriminant delta, which is positive. It wouldn't necessarily be 88, but it would be a positive number. Now, what if delta is equal to 0? Well, if delta is equal to 0, then you have 1 real root, or we can say 2 equal roots. And we gave an example of this parabola here, or this quadratic equation. If I write that down as a factorised quadratic, there we go. So x minus 1 squared is equal to x squared minus 2x plus 1. I could write that parabola as x minus 1, x minus 1. Okay, so let's just say, and I had a 1 there, this is the parabola. So I've got only 1 root, but actually I've got 2 roots which are equal at x equals 1. Okay, so if I've got delta equal to 0, I could have that concave up or concave down parabola. If it's concave up, it touches the x-axis at the vertex, and it's concave down, again it touches the x-axis at the vertex. Now, last of all, if delta is less than 0, if delta is less than 0, then there are no real roots. That means the parabola has no x-intercepts. So there's 2 possibilities here. You could either be concave up and above the x-axis, or you could be concave down and below the x-axis. Now, what can you say about the parabola if it's above the x-axis? Well, and it's concave up, you can say that A is greater than 0. And if it's above the x-axis, no x-intercepts, delta less than 0. But the other interesting thing is you could say that the y values of the parabola are always positive. So y value is always bigger than 0. And what's the general equation for a parabola? Well, we know that y equals ax squared plus bx plus c. So we could say that we could say that y is bigger than 0, but we could also say that in another way. We could say that ax squared plus bx plus c is bigger than 0. Because if you think about it, if y is bigger than 0, then ax squared plus bx plus c must be bigger than 0. Okay, for the last one there, if you've got a less than 0 and no x-intercepts, that means obviously delta is less than 0 because you've got no x-intercepts. Now the other interesting thing is, what can you say? You can say that the y values for the concave down parabola with no x-intercepts are always negative. Now again, because we know that y is equal to ax squared plus bx plus c, instead of writing this, okay, we could write this. Ax squared plus bx plus c is less than 0. Okay, so this part here that I'm circling is just saying that the y values of a concave down parabola with a negative discriminant are always less than 0. Okay? Alright. Now, let's look at the first question here. Show that this equation has no real roots. So that means all I've got to do for my first answer is I've just got to show that delta is less than 0. So I'm going to calculate delta. That's going to be 1 squared minus 4, 2, and then 4. Right, so it's going to be 1 minus 32, which is minus 31. So all I've got to do then is say delta less than 0, which implies no real roots. Okay. Let's look at part B. Part B says describe the roots of the equation. Okay. So let's look at the first one again. Calculate the discriminant. So you've got delta is equal to 2 squared minus 4. 1 second. That's not right, is it? No. Let me throw that out. Delta for this guy here. B squared, so it's negative 7 squared minus 4ac times 2 times negative 1. So if I calculate that, that's going to be 49 minus 4 times 2 times minus 1. You're going to get 57. Now that is not a square number. It's positive, so I would say my answer for this would be delta is bigger than 0. So I've got 2 real. Now because this is not a square number, I would say 2 real irrational roots. Okay. Now let's look at the second one. X squared plus 6x plus 9. Okay, so for x squared plus 6x plus 9, let me just check that. Yep, equals 0. Okay, so let's find the discriminant for that. So delta is 6 squared minus 4 times 1 times 9. So that's going to be 36 minus 4 times 36. 36 minus 36, which is 0. Okay, so we've got a 0 discriminant. So that means we have 1 real root and it's rational. Okay. Now, what about the last question? So, the last question says find values. Okay, so let's do that. Scroll up a little bit. So, see, now I've got 1 minute left on this video, so I've got to be quick. I've got a 30-minute limit. Okay, so just quickly looking at this, for real roots, you'll show delta is bigger than or equal to 0. So we solve the discriminant bigger than or equal to 0. If you work that inequality through, and don't forget when you're dividing by negative 20, you have to reverse the inequality sign, and you should get this. So when k is less than or equal to 1/5, the roots are real. So for part A here, to show that a parabola has 2 x-intercepts, you just have to show that the discriminant is positive. So we've got the discriminant equal to 9, and that means it's got 2 x-intercepts. For the last one, I'll go through that again at the beginning of the next video.